Good morning, kiddos. Hope everybody's doing great. Um, Shout out to Addie girl. I miss you in class. You have been learning about different types of energy. We are going to be learning specifically today about electrical energy and how it can travel in a current. So there's two terms I want you to pay attention to really closely when we're watching this video. So an open circuit and a closed circuit. And what do those mean? So first, Moby and Tim are going to talk about what circuits are and how they work. And then they're going to talk more specifically about those open and closed circuit. And we'll stop and talk about it as we go.
Don't stay plugged in too long. Mom said our electric bill was going nuts last month. Dear Tim and Moby, what is an electric circuit made of? From Joseph P. A circuit is a way of routing electricity along a path.
So this part's really important. Notice the way that this bulb is, or whatever is put into the circuit, is hooked up. So we've got energy flowing from the positive side of the battery to the bulb, out of the bulb, and into the negative side of the battery. What you really need to pay attention to here is a circuit is a complete loop.
Electricity happens when electrons, the negatively charged particles in an atom, move from one place to another. Electricity is nearly instant in the natural world. Think of a bolt of lightning or when you get a shock from touching someone. Right, those are examples of static electricity. It's actually not all that useful as a power source because all the energy is released all at once. Now, in order for electricity to be useful, we need a steady flow of it, a current. An electric current doesn't just happen on its own. It needs a path to follow. And that's what a circuit is, a path that a current can flow along.
Let's look back just really quick. So I really like this picture. The circuit is a path that the current can flow on. So the circuit is the complete path that the current can flow on.
Well, yeah, but you need more than just a wire. Even the most basic circuit is made up of a few different components. First, there's a power source, like an outlet in the wall or a battery. The power source provides a steady supply of electrons. In the battery, the electrons come from the negative terminal. From a wall outlet, electrons come from the shorter of the two slots, called the hot slot.
I wonder if you've ever noticed that when you're looking at an outlet, one of the lines, they're parallel to each other, but one of the lines is bigger than the other, which helps electricians know what side of the energy is flowing out of.
The electrons need a path made of a good conductor, which is any material that allows electrons to move through it easily. Most metals make good conductors, so we use metal wires as paths in electric circuits. Yeah, the wires are surrounded by rubber or plastic because those materials are good insulators. Insulators are kind of the opposite of conductors. They're materials that electrons have a hard time blowing through. Insulated wires keep electrons on course, and they protect us from the dangerous flow of electricity going through their metal cores.
And Miss Pergram is going to talk to you guys a little bit more about this tomorrow.
Along the circuit's path, there's usually a load, a device that uses electricity. Electrons flow through the device, giving it power. When they flow out of the device, they head towards the opposite side of the power source. In a battery, that's the positive terminal. In a wall outlet, that's the taller of the two slots, the neutral slot. And that's the real key to an electric circuit. The electrons have to have some place to go. Without it somewhere to flow into, the electrons will stop moving. You no longer have a current.
So if you notice here, this circuit is now broken and energy is no longer flowing at all. It's not even coming out of the battery, even a little bit. It's not flowing at all.
wires. Electrons flow out of the hot slot, down one of the wires, into the load, into the wire on the other half of the cable, and back into the neutral slot. Oh, right. Well, to control whether an electric device is on or off, you need a switch. A switch controls the flow of electrons by opening and closing the circuit. When a switch is in the off position, the circuit is open. And when it's in the on position, the circuit is closed and the electrons can flow through. Well, I think.
So I'm going to go back really quick because I want to talk a little bit more about an open and closed circuit before we move on. I want to get back to, where is it? The picture I want. Oh, my lights just turned off on me. Thank you. Okay, my lights are back on. So if you look at this circuit on your screen right now, you notice that it's a complete loop. It's connected to the negative, the positive side, and the load, which is right now our light bulb. You could put a buzzer in there, a microphone in there, microwave in there, whatever device you want to put in. But right now it's a closed circuit because it's a complete loop and energy is flowing. As soon as, something is taken out of the circuit, it's now an open circuit. And I like to remember it because the loop is now open and energy is not flowing anymore. Moby and Tim talked about this you could make this a switch so you could turn things on and off, because as soon as you put that wire back in, then it makes a closed circuit and energy is going to flow. So what I want you to do today for your Google exit slip is go to Google Classroom, and your question is going to be, what makes let's do open circuit? And remember, an open circuit has a battery and the wires and the bulb that make a complete loop and energy is flowing. Alrighty, kids, have a great afternoon. Bye.